Hi guys, this will be our very first flipped classroom. It is an easy lesson to get started with, as most of the information is really already given to you in the handout. Not just that, but you also have been working with quadratic functions for quite some time, so a lot of that information should be familiar. If it is not, we need to be reviewing a ton of that information. We only have one lesson to cover quadratic functions. And the very first thing that I want you to spend a minute and look over is the basic characteristics of a quadratic function. Let's see. Okay, purple looks pretty good. There are two different graphs introduced in here. I wish that wasn't the case, but you do remember that the graph of a quadratic function is a parabola, and that it could be either facing up or facing down based on the coefficient in front of x squared. Well, that coefficient in this case is shown as a. The domain and the range are shown for both the smiley face and the frowny face, as I like to call them. And then you can also pay attention to the intervals where your function would be decreasing or increasing. We do know that a quadratic function is an even function, as it is symmetrical across the y-axis. And for the parent quadratic function, we can find the relative minimum or the vertex at 0, 0. And if it is a frowny face, then the vertex is still 0, 0, but in that case, the vertex would be a relative maximum. The next thing that you guys have on your handout are the basic characteristics of a quadratic function. We already talked about when the parabola would be opening upward and when it is opening downward. Some of the things that I want you to please pay attention to on here are just this general form, ax squared plus bx plus c. And some of the vocabulary that if you need to review, let's go ahead and do that. Some of the vocabulary that we will be using is vertex. We'll talk about axis, and this is the axis of symmetry. Your axis of symmetry will always be located at the x coordinate of the vertex point. And that's it on this page. Really, just take a minute, read over it, and let's go on over and flip on the other side of your handout. So here we talk about the standard form of a quadratic function. You guys have seen that form before. However, most other textbooks would call this the vertex form. I really wish that this was the name that this notebook was using as well, but here they call it standard form. So the good thing about this form, I would continue calling it vertex form. In this form, it is very easy to automatically find your vertex. Your vertex is always going to be the point hk, where h is the number subtracted from x and k is the number added on the outside of the function. We do have to pay attention to that coefficient on the outside of the quadratic so that we know if the parabola opens upward or downward and whether it has a stretch or not. I want you to please note that this is also the form that shows your transformations really well. Oh, I don't know if you can hear the squeak of my pen that I'm using. This here will show your transformations. Okay, So very easily, if we know the parent function, which all of you know how to graph a parent function of y equals x squared, if you know how to graph that one, and you are able to get a quadratic function into this vertex form, very easily you can graph your new function as well, simply by using function transformations. We are going to go ahead and look at the example. We are going to write a quadratic function in standard or vertex form. So our first step would be to actually complete the square to get that into standard form. And then we're going to graph the function and describe the transformations in comparison to the parent function. We have to identify the vertex, minimum or maximum axis of symmetry, and then of course any x-intercepts, domain, range, and end behavior. So let's get to it. So one of the first things that we might want to do when we're trying to convert this function into vertex form would be maybe to factor out this negative sign. Now we have negative quantity x squared plus 4x plus 21. Factoring out the negative sign automatically shows me that I will have a parabola that will be facing down. Now, to be able to convert into that form, we will be completing the square. Just a reminder, when you're completing the square, you are looking for two square terms plus or minus 2 times each of the square terms. The 2 times each of the square terms will show up from 4x. So it might be helpful to actually rewrite this slightly. And now we have minus x squared plus 2 times each of my terms. 2 times 2 times x. Well, since I need to have two terms, I already see my x term, and I have it squared. The 2 just comes from the formula itself. That means that my next term to complete the square is this 2. Now I am missing this term squared. I actually need to add that missing part, which is 2 squared. And as I've said many times before, you can just add something to an expression because then you are changing its value. Since we're trying to keep the value the same, if I added 4 here, I will go ahead and subtract 4 as well. Okay. I once again just manipulated an expression. As long as I am not changing its value, then it's all good. I am manipulating it in a format that would be helpful for me to complete the square. I still need to add that 21 from the original expression. Now I can go ahead and write that completed square in a quadratic format. That gives me minus, and I have x plus 2, the whole thing squared. If you are not certain of what happened here, we certainly will be reviewing completing the square. I highly recommend going on Khan Academy and just trying at least 3 problems. Just type in completing the square. It will show you plenty of examples, and you get to try a few to remember once again what was happening. Now, the part that I wrote out here is just the x squared plus 4x plus 4. I still have this minus 4. For me to take that out of the parentheses, I need to make sure that I also multiply it with the negative on the outside of the parentheses, which gives me plus 4. And I still need to write out that plus 21. We're almost there, guys. We have negative x plus 2 quantity squared plus 25. This is the final form of my equation. It is now in standard or vertex form. Having it in this form, I can easily see my transformations. My transformations are 2 to the left. I also have 25 going up. And I have a negative on the outside of my quadratic, which shows flip across the x-axis. Okay. Well, yeah, that makes sense. We do know that we will have a frowny face rather than a smiley face. The next thing that we need to do is identify the vertex. Let me see if I can change the color here really quickly. To identify the vertex of the equation, remember that it was the h and the k from the original formula. To identify the vertex, it is always going to be negative the number inside the quadratics. So the vertex is at -2, y coordinate is 25. We also have to identify the minimum or maximum. Well, the minimum or maximum of a parabola always occur at the vertex. However, you do have to specify, is this going to be a minimum or maximum? Since it is a frowny face, the vertex will be at the top, which makes this vertex a maximum value. We'll talk about the axis of symmetry. Actually, we can do it right here. Axis of symmetry always occurs at this x point from the vertex. So axis of symmetry happens when x is equal to -2. We have to look at x-intercepts. We can do that a lot easier when we graph it on the graph. So we'll talk about the intercepts here in a minute, but we can absolutely look at the domain and range. When we talk about a domain of quadratic function, there are absolutely no limitations to the x values that you can assign. That means that your domain is going to be all real numbers, or from -infinity to +infinity. Your range is going to, in this case, we have a frowny face, so the range will start at the negative numbers, and it goes up to the maximum value, which is 25. It happens at the vertex point. And we also have to talk about end behavior. The end behavior is that the function is falling in both directions. That's really all we need to say for this. Okay, now let's go ahead and graph it. When we're graphing, it might be helpful to just go ahead and notate a few of the values on our graph. For graphing purposes, each one of our squares will be equal to 2 units. That means that 25 will be right up here at the very top in between the lines. Now remember that my vertex is at -225. So to find my vertex, the point will be located right here. Oh God, it's not working on my little tablet that I'm using. Let's see if I can easily just put a little dot. Nope. Okay, I had some technical difficulties, but I was able to plot the vertex right around where it should be. -225. Once again, each of the squares is equal to 2 points, so the vertex would be somewhere around here. Since our graph really cannot work very well, not for me at least, not with the tablet that I'm using, but our graph will be a parabola going in that direction with the specified vertex. Please, as you are taking your notes, aim to have at least showing the vertex properly, and then you would be going downwards. Now, I told you that using the graph would be helpful to get our x-intercepts. However, it will not work for here because our graphing is not very easy. So let's go ahead and solve very quickly for our intercepts. To find our x-intercepts, we're really asking ourselves, when will the graph or the function be equal to 0? So we can just go ahead and solve the equation. We have the original function, and all we have to do is set it equal to 0 and solve the equation. I say all we have to do, however, you guys might not remember how to do that. We have several ways to approach a quadratic equation. We can try to factor it. We can try many different ways. However, we can try to graph it. One way that always works no matter what is the quadratic function. And that is, just so you guys can remember it, that formula was that x is equal to negative b plus minus square root of square root of quantity b squared minus 4ac. All this is underneath the square root. The whole thing divided by 2a. Well, before we get to this formula, it might be helpful to get rid of some of these negative signs and then see if this would be our approach. We have that x squared plus 4x minus 21 is equal to 0. If I try to factor it, then I'm thinking, is there a number or are there two numbers that multiply to give me 21 and add together to give me 4? 7 and 3 might work. Let's see. If we did x squared plus 7x minus 3x minus 21 is equal to 0. Oh, guess what? It looks like we can factor it. That gives us x plus 7 minus 3 times quantity x plus 7 is equal to 0. It means that we can actually factor to x plus 7 times x minus 3 is equal to 0. If you remember how to factor directly from this all the way down to this factor form, by all means, you can go for it. We wanted to factor because from here we can solve the equation. Our x-intercepts are x equals to negative 7 and x equals 3. So these will be our x-intercepts or our zeros. Quadratic functions are lots of fun. I wish we had more time on them, but we will only have one day. So if you need to review how to complete the square, please do so through Khan Academy. Do at least 3 problems. And that's it. Thank you guys for bearing with me. I hope that I can figure out a better way to make the videos so that it can be even more beneficial. I will see you all tomorrow.